Have you ever questioned what everyone believes? Playing shooter games improves your eyesight. Puzzle games treat trauma. And a gaming addict's brain looks almost identical to a gambling addict's. Same activity, opposite outcomes. Why? The answer lies in which brain circuits dopamine stimulates. Let's set aside the idea that games are just entertainment. From a neuroscience perspective, every game stimulates the dopamine system. In Koepp's 1998 PT scan study, dopamine release increased by 100% during gameplay. For comparison, food causes a 50% increase and cocaine 25%. But here's the key. Dopamine itself isn't the issue. Dopamine isn't a pleasure chemical, it's a learning signal. It tells your brain which behaviors to repeat. The problem is that different game genres tie entirely different brain circuits. First-person shooters train the visual cortex and attention circuits. Daphne Bavelier's research team had subjects train on shooter games for 50 hours, and their contrast sensitivity improved by 43%. That's an ability even glasses can't correct. Strategy simulations train the prefrontal cortex. A group that played StarCraft for 40 hours showed significant improvements in cognitive flexibility, the ability to monitor multiple situations simultaneously and switch between them. Puzzle games activate even more surprising circuits. In Holmes' 2009 study, a group that played Tetris right after a car accident experienced 62% fewer trauma flashbacks. Tetris occupied visual working memory, preventing traumatic from consolidating. In a study of surgeons, those who gamed at least 3 hours a week made 37% fewer errors and were 27% faster. The circuits games trained were actually working in the operating room. But the same dopamine system can also destroy circuits. Games that combine endless progression systems, random rewards, and social obligation are especially dangerous. When dopamine repeatedly stimulates only the reward circuit, the prefrontal cortex weakens. That's the region responsible for impulse control. In 2019, the WHO officially classified gaming disorder as a disease. Global prevalence is 3%. Among Korean male adolescents, it's 10%. Scan an addicted brain, and you'll find patterns nearly identical to a gambling addict. See the pattern. Shooters train visual circuits, strategy trains the prefrontal cortex, puzzles train working memory. But overstimulate the reward circuit, and self-control collapses. Same dopamine, but which circuit gets hit and how much determines everything. A meta-analysis of 37 studies found that gaming's cognitive benefits had an effect size of 0.64, above moderate, but only when playing specific genres for appropriate durations. Ultimately, games are tools that selectively train specific brain circuits. Which genre you choose determines which circuits you grow, and how much you play determines whether those circuits get strengthened or destroyed. Your brain is being trained right now, at this very moment. By the way, if you have a game open in another tab while watching this, your dopamine is weighing which circuit to stimulate right now. This video or that game.